Hi, I'm Betty. I come from AWS Greater China Developer Relationship Team. I'm a Senior Developer Advocate. As you know, GitOps simplifies both application development and operations tasks with Kubernetes. So I would like to use a demos to show how to build a scalable, complete GitOps system on AWS that addresses the needs of both application team and platform team. GitOps is an approach where infrastructure is defined as code, alongside application code, versioned in Git repository, and then provisioned following the same merge request process as application software code. Using Git as a single source of truth is a game changer for DevOps. It lets you standardize and automate everything from code to config to infrastructure in one place. No more worrying, is this environment up to date? With GitOps, we track changes in Git just like we do with application code. Your inter-systems become versioned and auditable. Rollbacks are simple with commit history and tags. Developers, ops folks, security, everyone is looking at the same repo. GitOps helps teams work together and move faster. Most importantly, you get reproducibility and consistency. Your infrastructure is defined as code in Git. Environment will match the desired state. There's no configuration drift. Bottom line, GitOps is huge for scaling DevOps. It's your single pane of glass for end-to-end automation. Leverage Git is the key to rapid, reliable delivery across application and infrastructure. Flux made GitOps happen on Kubernetes. It's a conductor that orchestrates everything behind the scenes. Flux is built as Kubernetes extension, so it belongs right into your cluster. You deploy it as a simple pod inside EKS or any Kubernetes environment. Flux keeps a close eye on your Git repo to make GitOps work. It tracks changes to your infrastructure and manifests. When you push a commit, Flux grabs those changes and applies them to your cluster. So Flux basically syncs your Git state with your live environment. It's always adjusting Kubernetes to match your desired state in Git. Any drift gets corrected automatically. The best part is that all happens continuously in the background. Flux just runs in your cluster as a service to enable GitOps. No manual task required. Many companies adopted Kubernetes in their production. They care about how to achieve continuous deployment, high security, permission separation, and auditing. We believe that GitOps can enable such continuous deployment based on Kubernetes cluster, while meeting enterprise-level requirements such as security and permission separation. I will demonstrate the GitOps workflow with a series of video demos. If you are interested, please follow the other demo video in this series. They are: number one, deploy cloud infrastructure with IAC. Second, deploy Flux CD on Amazon EKS cluster, and then deploy GitOps workflow with Flux CD. Last, image-based automated deployment with GitOps workflow. These demos show in detail how to set up a production-ready GitOps workflow on Amazon EKS. You will see how microservices can achieve continuous delivery through a GitOps CI/CD pipeline. In this demo, I will use a front-end project. It's a project name as an example. And under code commit repo, I will create 3 code repositories. One is a Flux repo. It's a config repository for Flux CD to define Flux resources. The other one is a microservices repo. It's store app configs and deploy manifests. The last one is app repo. It's as a resource repo for the front-end services. For CI, I will use code pipeline to build images on commit and push them to Amazon ECR. Flux CD is deployed as a pod in EKS to enable GitOps deployments. Demo 1, deploy cloud infrastructure with IAC. We will understand what's the IAC. We created a custom EKS cluster with CDK and installed the AWS application load balancer plugin in this demo. And first, we should understand what's the AWS Cloud 9. AWS Cloud 9 is a cloud-based IDE that lets you write, run, and debug your code with just a browser. Create a new TypeScript CDK project. Run CDK init. This will generate the required folder structure and install the necessary modules for the TypeScript CDK project. Use nmp to install EKS blueprint. It will help to quick build a complete EKS cluster. Open the quick-start.ts file in the lib directory, which is the entry point to the CDK project. Create a pipeline TS file in which we will define the infrastructure and resources needed for our demo. In here, the cluster provider provides the entry point for modifying cluster parameters, which EKS blueprint manages the plugin running the Kubernetes cluster modularly. So you can add cluster plugin on demand. Open quick-start.ts in the bin folder and modify the stack parameters. By default, the stack will deploy using the current user credentials if not changed. In the console, use CDK list to check the defined stack resources from previous step. Deploy the pipeline stack with the CDK deploy command. Create EKS cluster isolated from each other in 2 regions. We prefer use CDK codes to define infrastructure and use a pipeline to manage your changes across multiple clusters. It's also the best practice of GitOps. Log in AWS console, open the page of code pipeline. Check the current state if the pipeline that we created in the last step to make sure 2 clusters have been created successfully. Yes, we can see that's all built it. Okay, log into dev cluster with kubectl command. Check the status of the namespace to make sure it's running properly. Use kubectl command to check AWS application load balancer plugin in the Kubernetes system namespace is installed successful. Demo 2, deploy Flux CD on Amazon EKS cluster. I will use a Flux bootstrap command to install Flux on Kubernetes cluster and will create 3 important configuration files: GOTK components, GOTK sync, and customization. We check the Flux repository in the code commit. In here, Flux repository is a Flux CD configuration library. It's used to define Flux-related resources. Go back to Cloud 9 and install Flux CLI. Flux CD synchronizes Kubernetes manifest from a source repository with a Kubernetes cluster by regular pulling the repository for changes. This keeps the cluster in sync with repository configuration, removing the need for manual status checks with kubectl or separate workload monitoring. Use git command to copy Flux repository to the Cloud 9. We proposed the architecture of Flux repository is to divide Flux-related resources into infrastructure layers, cluster manager layer, and application layer. It will support multi-cluster deployment by customization. Create a new template file to modify the Flux bootstrap command. Replace username and credential in the Flux bootstrap command with a code commit credential that created before. Okay, run the Flux bootstrap command and wait for Flux to start up. Okay, use the git pull command to check the changes in Flux repository. In here, we will see 3 new files created by bootstrap. Use the Flux get customization command to view Flux resources changes in the real time. When all readies become true, the creation is successful. Use kubectl command to review the controller in Flux namespace. Now, there are 6 controllers created successful. Demo 3, deploy GitOps workflow with Flux CD. In this demo, I will demonstrate how to configure multiple clusters by a microservices business application, how to build a standard GitOps workflow based on Flux, and how to manage the application's resource file with a practical Kubernetes configuration management tool. Microservices repository is a code commit, is a new project which is used to store configuration and deployment file. Back to Cloud9, use git command to copy microservices repository to Cloud9. We create 2 libraries of the customization required. They are base and overlays development, and then copy the manifest file of microservices to the base library. Create a customization file in the base library. Open the customization file in Cloud9 and modify its contents. Index manifest file of microservices in codes through customized resources. Create a customized file in the overlays development library. Index all manifest file with customized resource. Submit microservices configuration changes to the Git repository. Flux multi-automatically merge base and overlay configs based on the environment during deployment. We recommend defining different configuration for dev, test, and prod environments. We prefer use different paths in one Git repo to manage multi-environment rather than multiple repo and branches. It's a single repo approach, single code. Maintenance and merging is a Flux best practice. Then log in the Flux repository, find the configuration in the app library. In tenant, we add the Git repository address to the Flux configuration. It ensures Flux monitor code changes. Create a new temporary file and convert code commits access credential to base 64 encoded format by command. Open Kubernetes security, add base 64 credential to data. Create a new app file in the dev cluster directory and index the microservices configuration with the path attribute. Submit changes of the Flux configuration file to the Git repository. Use Flux command to ensure the configuration takes effect. During this time, Flux regularly scans the code repository. It automatically syncs any app changes to the cluster when configuration changes happened. Now we can see our previous configuration changes have taken effect. We check whether microservices has been deployed successfully with kubectl command. We can see all the access address of the load balancer from output of the console. Now visit the web page of microservices with this address. All changes have been take effect. Demo 4, image-based automated deployment with GitOps workflow. We choose the front-end microservices of Sockshop as an example to demonstrate the detailed process of code changes, image building, and customized released with GitOps workflow. Log in AWS console, check the build spec and source console codes of front-end in code commit. In this demo, we use code pipeline to build a front-end continuous integration pipeline and release image in Amazon ECR. So we check the latest version of image files in Amazon ECR is available. Let's return to Cloud9, modify the resource list file in microservices repository, and define the Amazon ECR image addressed to the front-end default image. The annotation here is necessary as it's used to define the name and version of the image file. Flux will use this annotation to define and modify contents when the version of the image changes. Okay, we use git command to submit image changes to Git repository. Open the source code of Flux configuration and modify the relevant configuration to make Flux image update automatically. Create a configuration file for the image repository. Port the front-end image address in Amazon ECR to Flux. It enables Flux to monitor changes of image repository. Okay, copy the URI of the image file from Amazon ECR to the configuration file of the image repository created before. We also need to configure access credential between Flux and Amazon ECR. We can use Amazon ECR to select the automated authentication mechanism. We modify the customization file and add the AWS auto login for ECR parameter by patching it to configure the access credential between Flux and Amazon ECR. Yeah, we create a new policy file. Use the policy file to define the rule which match images. Images will be triggered by automatic development only when the rules are met. Created a new image automation file. We will define information of the microservices resource list in the new image automation file, which includes Git repository, branch, commit, and so on. Then we modify, customize, and add all the above-mentioned files to the resources. We use git command to submit these changes. Use the git command to copy microservices repository to Cloud9. We modify front-end source codes and do some simple changes for the footer. It helps to verify changes in the future. In this demo, we changed the year of the footer. Changes of front-end code will automatically trigger the continuously integration workflow of code pipeline. It creates a front-end image and pushes them to Amazon ECR. We can see the version of image file in Amazon ECR has updated successfully after the continuous integration pipeline has been executed. Okay, back to Cloud9, we use code command to see that Flux has monitored changes of the Amazon ECR image and start to execute GitOps pipeline. Open the microservices repository in code commit. Verify that the image version in microservices resource list has been updated to the latest. Okay. Let's use the kubectl command to check port information and confirm EKS front-end service is the latest version. Okay, check the version of port image. Verify it has been updated to the latest version. All changed, all updated. Finally, we visit the front end page to confirm that the changes to the footer have taken effect. Yes, the year of the footer has taken effect.
What an amazing video! Please give us a like if you thought so too, and don't forget to subscribe to this channel, hit the bell notification so that you get notified whenever there's a brand new video uploaded to build on AWS.